The Syntax of Boolean Logic by Aidan Delaney and Genevieve Smith-Nund. Hello and welcome to the third video in the series titled Propositional Logic. In this series of videos we explore the reasons for developing the formal system of propositional logic, and we look at deduction using propositional logic. In the previous video we asked why we might want to formalize an argument. Furthermore, we considered three aspects of a formal system. These are 1. A list of symbols used in the system, 2. A definition of the meaning of each symbol, and 3. A number of rules for combining systems in the system. In this video, we will consider each of these three aspects in the context of Boolean logic. We first look at the symbols allowed in statements in Boolean logic. In our definition of Boolean logic, we allow each of the characters capital A to capital Z of the Latin alphabet to be propositions. Two special characters, namely top and bottom, are also propositions. A negation symbol, which can be placed in front of any proposition, and the symbols wedge and V, which are connectives for propositions. We also allow the use of parentheses. This is useful information insofar that it tells us that the % sign or the $sign are not symbols that are used in any statement in Boolean logic. Do note, however, that we could easily add these symbols should we so wish. In many definitions, people use the symbols dot, plus, and tilde in place of the wedge symbol, the V symbol, and the negation symbol, respectively. The choice is wholly one of convenience and culture. What this information has not told us is how we can combine the symbols to form a sentence in Boolean logic. As an example, you may know that the sentence open parentheses, capital A, capital B, capital C, wedge symbol, close parentheses, is not allowed in Boolean logic, even though it only contains the characters that are allowed. Therefore, we need to define how to form sentences in Boolean logic. One way of doing this is to state that the top symbol is a sentence. The bottom symbol is a sentence. If alpha is any letter from the characters capital A to capital Z, then alpha is a sentence. If alpha and beta are sentences, then alpha wedge symbol beta is a sentence, and so is alpha V symbol beta. Finally, if alpha is a sentence, then the negation symbol followed by alpha is a sentence. So, why have I gone all crazy and used some strange Greek symbols here? I simply need some placeholders to mean a particular Boolean logic sentence. This is more clear if we look at some examples of sentences and why they are sentences. By definition, the top symbol is a sentence. Also by definition, the bottom symbol is a sentence. If alpha is any letter from the characters capital A through capital Z, then the alpha symbol is a sentence. Therefore, capital A is a sentence. Capital B is a sentence, or capital P is a sentence. I won't enumerate all 26 letters here. Furthermore, the limitation to 26 letters is entirely arbitrary. In my experience, we rarely need more than 5 or 6 letters when representing simple systems in Boolean logic. If we need more letters in our system, then we can always add them. If alpha and beta are sentences, then open parentheses, alpha, wedge symbol, beta, close parentheses is a sentence. As we've already established, capital A is a sentence, then open parentheses, capital A, wedge symbol, A, close parentheses is a sentence. Another example of a sentence is open parentheses, A, wedge symbol, top symbol, close parentheses. Furthermore, because A, wedge symbol, A is a sentence, we can join it with another sentence. Open parentheses, A, wedge symbol, A, close parentheses, wedge symbol, top symbol, close parentheses is a sentence. We can have similar examples when considering the V symbol in place of the wedge symbol. Finally, if alpha is a sentence, then the negation symbol followed by alpha is a sentence. Examples of this are negation symbol followed by capital A, or in a more complex example, negation symbol, open parentheses, A, wedge symbol, A, close parentheses, wedge symbol, top symbol, close parentheses. All of the above allows us to combine the allowed symbols in the allowed manner. We have defined what we call the syntax of Boolean logic. The syntax doesn't tell us what each of these symbols mean. We now define the meaning of each symbol, but first we must consider what meaning means. Actually, in order to get some real work done, we're not going to worry about what meaning means. I hope that we can agree that sets exist, that you can refer to, say, the set of all tigers, the set of all grains of sand, or the set of all positive integers. Actually defining what a set means is difficult and requires a long detour into philosophy. There's a very interesting intersection between philosophy and the foundations of mathematics, on which we build Boolean logic and the entirety of computer science. To conclude, in this video we've considered how to write sentences in Boolean logic. We've defined the syntax of the logic. In the next video, we shall consider the meaning of each of these sentences, that is to say, the semantics of Boolean logic.